Today we're going to talk about key features of linear graphs. All right, we're going to talk about intercepts, zeros, and slopes. The first thing we're going to discuss are intercepts, and an intercept is where a graph, could be just dots or it could be a line or a curve, is where a graph touches an axis. All right, that means that the x-intercept is where a graph touches the x-axis, and a y-intercept is where a graph touches the y-axis. It's important to remember that with intercepts, they are ordered pairs, right? Those are coordinates, they're points on a graph. So whenever you're talking about the x or the y-intercept, you have to remember that it's a point, so it has an x value and a y value. That's what gives us the ability to plot that point. So it's important that whenever you talk about intercept, that you include both the x and the y value for each one. Now let's talk about the x-intercept. All right. You can see below, you can see on the screen that I have a coordinate plane with my y-axis on the top and my x-axis on the side. All right. Y goes top to bottom, x goes left to right. So for the x-intercept, we're looking for the point where a graph would touch the x-axis. So this horizontal line going from left to right. It's important to remember, as we just mentioned, that the x-axis or the x-intercept is an ordered pair. Okay, that means it has an x and a y value. But the y value, no matter where the x-intercept is always going to be 0. So I can draw a line. I'm going to zoom in a little bit so you guys can see better. If I draw a line on my coordinate plane, you can see that our x-intercept would be right here where it touches the x-axis at that dot. The ordered pair for that dot would be, for x it would be positive 1, 2, 3. So my x value would be 3, and my y value would be 0. All right, if I go above it, this is 1, this is 2, this is negative 1, this is negative 2. So that means that the y value anywhere on the x-axis is always 0. So that would be 0. Doesn't matter where I draw my line or where it touches the x-axis, the y number is always 0. I could draw another line over here. And you see it's touching at this point right here. So this point would be where x is negative 1, negative 2. So our x value is negative 2. And the y value is still 0, okay, because it's still on the same line as this original x-intercept that we just drew. So no matter where on the x-axis the line touches or we place the point, the y value for the x-intercept is always going to be 0. Another word that we use for the x-intercept is 0. Okay. That's another way to describe it. Anytime you're asked to find the 0 of a function, they want to know what is the x value of the x-intercept. So the 0 of this particular function right here would just be 3. Okay? The 0 is like the solution to a problem. It's just one number. It's not a point or a coordinate or ordered pair. So the 0 of this particular function right here that I drew is just 3. The x-intercept is the point 3, 0, but the 0 is just 3. This one over here, the second one that we drew, our 0 would just be negative 2. That's the x value of the x-intercept. Okay, for this function that's going that way. So while the ordered pair or the x-intercept is this point, negative 2, 0, the 0 of this function is just negative 2 because that's the x value. Next, let's talk about the y-intercept. So the y-intercept is where our graph is going to touch the y-axis. The y-axis is the one going up and down. All right. So we can draw any line anywhere. Here's a line right here. And you can see that this is where our line is touching the y-axis at this point. So for the y number, this would be zeros here, -1, -2. So my y value, or the second coordinate, is going to be -2. The x value for this dot is going to be 0. This would be +1, +2, +3, -1, -2, -3. So you can see it lines up with 0 for x. So any point touching the y-axis, the x value is always going to be 0. So this would be the y-intercept of this particular line. If we drew the line anywhere else, we drew another line. Oh, it's kind of crooked. So this line right here, we got a new function. The y-intercept is touching right here at this dot. So that would be 0 for x, because it's on the y-axis. And you can see it lines up with the 0 as we're counting the x numbers. And our y number would be +1, 2, 3, 4. So the y-intercept for this particular point on this function would be the coordinates 0, 4. So to recap with the intercepts, the x-intercept always has a y value of 0, and the y-intercept always has an x value of 0. The last key feature that we want to cover with lines or linear equations would be to find the slope. Now the slope describes the direction and the steepness of a line. A negative number means that it goes down from the left to the right, and a positive slope number means it goes up from left to right. The steepness is how slanted the line is. The bigger the number, the more steep a line is. And a steep just is talking about the slant it is. So less steep would be flat, more steep means more slanted. So we're going to draw a line, just a random line through the graph. And in order for me to calculate the slope, I want to find 2 points that I can use. So here's a point right here at the x-intercept, and here's another point up here. So in order for me to calculate the slope, I want to use the rise over the run. Okay. I'm going to see how much I have to go up or down first, which will tell me if it's going to be positive or negative. If I go up, my slope is positive. If I go down, my slope is negative. And then I want to see how many spaces I need to go over to the right. So here, my rise, starting here, I got to go up 1, 2, 3, 4, 5 squares or 5 units to get even with the next point. So my rise on this particular one would be 5, which will be the top of my fraction. And then my run, or this is also the change in the y. We went from 0 in y all the way up to where y is 5. And then for my run, I have to go over I have to go over 1, 2, 3, 4, which is how my x's changed. My x's went from +2 to +6. That's a change of 4. So my run, or how much I went over, is 4. So this would be the slope of my line. This tells me how slanted my line is. The fact that the numbers are positive means that it is a positive slope going up from the left to the right. Let's look at an example of a negative slope. Draw another line. So we need to find 2 points on this line. Got one right here. And we're going to say another one is right there. So again, I want to find my rise over my run. I want to know how much I'm going up or down first, and then how many I have to go to the right. So starting here, I want to go from here down here to where it's even with this. I have to go down 1. I'm use the red for the rise like I did the last time. 1, and then 2. Okay. So I had to go down 2 squares, 2 units, and since I went down 2, my rise number is going to be -2. Now my run number, how many I need to go over to the right, is 1, 2, 3, 4, 5. I have to go 5 units to the right. So my slope for this particular function is -2 over 5. It's negative because I'm going down from the left to the right. And then the 2 and the 5 tell me that I went down 2 units or 2 squares and I went over 5.